Hello, good afternoon, all of you who are listening SE Radio Parsala on your very own favorite radio station, Radio Sarangi 101.3 MHz from the station of Virat, as well as you are watching us on the YouTube channel of nispakshakhabar.com. Today, we'll discuss some knowledgeable type of question which come under 1 mark in your SE examination. Okay, dear students, in our previous class, we have learned about Mendeleev's periodic table, modern periodic table, their laws, their merits, and their demerits. Today, at first, we are going to discuss on some knowledgeable type of question which comes under 1 mark in your SE examination from this chapter. First of all, we have Mendeleev's periodic law. Now, let's know the definition of Mendeleev's periodic law. It is given by the chemist Mendeleev, and it states that the physical and chemical properties of elements are the periodic functions of their atomic masses. So, if the question state Mendeleev's periodic law is asked in the examination, then you have to write in this way for getting 1 mark. It states that the physical and chemical properties of elements are the periodic functions of their atomic masses. That means in our previous class also we discussed on this law that Mendeleev he classified the elements on the basis of increasing atomic masses. Now number 2, we have modern periodic law. Modern periodic law. State modern periodic law. It states that the physical and chemical properties of elements are the periodic functions of their atomic numbers. So, modern periodic law states that the physical and chemical properties of elements are the periodic functions of their atomic numbers. You can see in these two laws only one thing is different there, that is in Mendeleev's periodic law there is atomic masses, means he classified the elements on the basis of increasing atomic masses, whereas in modern periodic law the elements are classified on the basis of increasing atomic numbers. Now another question we have: what are halogens right there group on modern periodic table? What are halogens? Write their group on modern periodic table. So its answer is the non-metallic and very reactive elements which react with metals to give halides, or halides means salts, are called halogens. They are placed in group 7A. Group 7A of modern periodic table. So, halogens are the non-metallic and very reactive elements which react with metals to give halides. Halides are salts, they are halogens, and they are placed in group 7A of modern periodic table. We have some examples of halogens like fluorine, chlorine, bromine, iodine. These are some examples of halogens. They react with metals to give halides or salts. So they are known as halogens. Now, question number 4. What are lanthanides? What are lanthanides? So its its answer is the group of 14 elements having atomic number 57 to 71 are called lanthanides. So lanthanides are the group of 14 elements, means in lanthanide group there are 14 elements having atomic number 57 to 71. They are known as lanthanides. Dear students, you know that lanthanides and actinides, they are placed separately at the bottom of the modern periodic table. Similarly, when we talk about lanthanides, immediately we remember actinides also. What are actinides? So, the group of 14 elements having atomic number 89 to 103 are called actinides. So, actinides also the group of 14 elements having atomic number 89 to 103. Similarly, we have another question. What are transition elements? What are transition elements? The answer is the elements whose d subcells are incomplete are known as transition elements. Are known as transition elements. So the transition elements are the elements whose d subcells are incomplete, means transition elements have incomplete d subcells. Similarly, question number 7. What is valency? What is valency? In your previous classes also, class 8, 9, 7 also, you may have read about valency. So its answer is, I think the students, you know its answer, the combining capacity of elements or radicals to form a compound. To form a compound is called valency. So that, dear students, valency means the combining capacity of elements or radicals in order to form a compound. That is valency. Similarly, question number 8. Question number 8. There is one principle in order to write electronic configuration of an element. Yes, you have got that principle, I think, and that principle is Aufbau principle. Aufbau principle. We can write the electronic configuration on the basis of subshell, that is SPDF, with the help of Aufbau principle. I think you have wrote the electronic configuration of different elements by Aufbau principle. So let's know what is Aufbau principle. Aufbau principle, or it states that the filling of electrons always occur from lower energy level to higher energy level. So, Aufbau principle states that the filling of electrons on shells or orbits always occur from lower energy level to higher energy level. This is Aufbau principle. Question number 9. What is chemical reactivity? What is chemical reactivity? So, chemical reactivity is the tendency of an element to take part in chemical reaction. Take part in chemical reaction. The atoms of an element may not be fulfilled by electrons. So, at that time, atoms of an element tries to lose or gain electron. That type of tendency or that type of property of an element is known as chemical reactivity. Sorry here, chemical reactivity. This is chemical reactivity. So, after this property, an atom of an element can be able to combine with another atom to give compound. Now we have another question. Question number 10. You have heard this term. What is or what are valence electrons? What are valence electrons? Dear students, you might know about the valence shell. Valence shell means the outermost shell of an atom. So, another thing, you know that in each and every cell, the electrons are there. Means electrons revolve in an orbit or shell. Valence shell means, first of all, let's know about valence shell. Valence shell means the outermost shell of an atom, and the electron found in that shell or in that valence shell are known as valence electrons. And the another thing is that the valence electrons losing or gaining of valence electrons determines the valency of an atom also. So, valence electrons are the electrons found in valence shell, or valence shell is also known as orbit. You can write orbit also, valence orbit of an atom. Valence electrons are the electrons found in valence shell, or shell is also known as orbit of an atom. Now another question we have, what is electronic configuration? What is electronic configuration? The systematic arrangement of electrons in different cells is called electronic configuration. You all know their strengths. An atom of an element has more than 1, 2 or 3 electrons. Means they may have number of electrons according to their atomic number. So all the electrons cannot be accommodated in single cell. You might have known about octet rule, duplet rule. The first cell can hold only 2 electrons. Similarly, second cell can hold 8 electrons and so on. In this way, the electrons of an element can be systematically arranged into different cells. Yes, the cells are also denoted by K, L, M, N cells. So the electrons present in an atom of an element are systematically on the rule. They are arranged into different cells. That process is known as electronic configuration. So till now we have discussed about 11 questions which is very important regarding your SE examination. I think you have copied these answers and questions. Now our 12th question. Question number 12. What are inert gases? What are inert gases? Mention their group in modern periodic table. Okay, what are inert gases? So its answer is the gases which are stable chemically and do not involve in any chemical reactions are called inert gases. They are kept in group 8A of kept in group 8A of modern periodic table. So, inert gases, or they are also called noble gases, are stable chemically and they do not take part in any chemical reactions. They are kept in group 8A, or 8A is also known as zero group of the modern periodic table. You can see if you see the modern periodic table in group 8A or zero group, you can see there helium, neon, similarly argon, krypton type of elements. Students, their outermost orbit or valence shells are almost fulfilled by the electrons, so that they are chemically stable. That means they do not take part in any chemical reaction. Now question number 13. What are metalloids? Give some examples. So, dear students, the different types of elements, they may be metals, non-metals, metalloids or inert gases. They are arranged in different groups of the modern periodic table. So among metals, non-metals, metalloids, they are also kept in our modern periodic table. That means there are some elements which are metalloids. I think you already have known about metalloids, though let's know its definition. The elements which show both the characteristics of metals as well as non-metals. Metals as well as non-metals are called metalloids. So, should know here that metalloids can show both the properties of metals as well as non-metals. You all know that some characteristics of metals, similarly some characteristics of non-metals. Because about metals and non-metals you have already known in your previous grades, previous classes. So if you have to define metalloids, you can define in this way: the elements which show both the properties of metals as well as non-metals. Now let's see some examples of metalloids. silicon, arsenic, germanium. Silicon, arsenic, germanium, etc. are the some examples of metalloids. Some examples of metalloids. Okay, this was our question number 13. Now I am moving question number 14 as well as 15. Okay, question number 14. What are alkali metals? What are alkali metals? They are also known as very reactive metals or elements. Very reactive metals. Okay. What are alkali metals? We'll know its place in modern periodic table, as well as we'll know some of the examples of alkali metals. First of all, let's know what are alkali metals. The metals, or we can write the very reactive metals, which react with water. The metals which react with water to give alkali. To give alkali are called alkali metals. The reason behind why they are known as alkali metals is that they form alkali. Alkali means metallic hydroxide. Alkali means metallic hydroxide. So that the reason behind alkali metals is that these metals, some of the examples, let's see some of the examples. Sodium, potassium, yes, they are two examples of alkali metals. They react with water to keep alkali. You can see NaOH, KOH. They are alkali. They are the metallic hydroxide. Sodium, potassium are metals. So they form this kind of alkali respectively, so they are known as alkali metals. They are placed on extreme left side of the modern periodic table. Their position is extreme left side of modern periodic table. Extreme left side means in group first A. You should always remember this because one of the frequently asking question is that the group of alkali metals or the position of alkali metals in modern periodic table. So alkali metals, also known as very reactive metals, they are kept in group first A of the modern periodic table. And why they are called so, or why they are called alkali metals? They are called alkali metals because they react with water to give metallic hydroxides, which are also known as alkalis. Similarly, another term I have used here is that they are very reactive metals. They are very reactive metal. Why they are very reactive metals? If you see the electronic configuration of the elements of group first A, then you can see they have only one electrons on their valence shell. Only one electron. Like if you see potassium, sodium, electronic configuration, first shell 2, its atomic number is 11, its atomic number is 19. If you see the electronic configuration of these two elements of group first A, then in first cell there will be 2 electrons, second 8, then in third cell there is 1 electron. Means this is the electron of valence shell. Similarly, in case of potassium, 2, 8, 8 and 1. Just I have taken these 2 electrons of group first A. 1 electron. And dear students, you all know that every atom of an element tries to attain its stable condition. So they lose that single valence electron from their outermost orbit easily, so that they are known as very reactive metals, as they easily lose one electron from their valence shell. So they are also known as very reactive metals. Now let's move towards another question. Alkaline earth metal. What are alkaline earth metals? I think question number 17. What are alkaline earth metals? The elements, or we can say metals also, the elements which react with water to give alkali and their oxides are found on the earth surface are called alkaline earth metals. Alkaline earth metals. Like alkali metals, alkaline earth metals also react with water in order to give alkali. And the another thing is that their oxides, means metallic oxides, are found on the surface of the earth. So they are known as alkaline earth metals. They are kept in group second A of the modern periodic table. Yes, if you see your modern periodic table on your book, then you may find metals like magnesium, calcium. Yes, these magnesium, calcium like elements or metals are known as alkaline earth metal. They are also reactive metals as they lose 2 electrons during chemical reaction. So I think we have known about alkali metals as well as alkaline earth metal. The difference between of group first elements, second elements, that means alkali metals and alkaline earth metals will be discussed later. That is also one of the very important question in difference between. Another question we have, define groups and periods. Define groups and periods. Dear students, different groups and periods are created in order to arrange similar and dissimilar type of elements. In modern periodic table, there was 7 periods and 8 groups. Whereas in modern periodic table, there are 7 periods and 18 groups. There was only 7 periods and 8 groups in Mendeleev's periodic table. Now, let's first define groups. The difference are also very important regarding understanding type of question, and the difference will be discussed later. Groups. The vertical columns of modern periodic table, or the vertical columns of periodic table. Just you can write periodic table. The vertical columns of periodic table are called groups. In groups, similar types of elements are arranged together. Like group first A, there are only alkali metals. In group 7A, there are halogens, which form salt when they react with metals. Similarly, periods. The horizontal rows of periodic table are called periods. Horizontal rows of the periodic table are called periods. In periods, we find dissimilar type of elements. If you see in your modern periodic table, I have told you many times that there are 18 groups, vertical, this type of groups where similar elements are kept. They are groups. Similarly, you can see this type of horizontal, this type of rows in your modern periodic table. You can find 7 rows, such kind of rows in your periodic table, which are known as periods.